Hello everybody, welcome into another lesson. So today we're going to have a couple theorems here, one about supplementary angles and one about complementary angles, and then all we're going to do today is 5 proofs and that'll be the lesson. So the first theorem here, the new one, states that if two angles are supplements of congruent angles, so if you have some angles that are congruent, and then you have two angles that are supplements or supplementary angles to those congruent angles, or the same angle, then the two angles are congruent. So when you're doing a proof, if you want to use this theorem, you would simply write supplement or sup of congruent angles are congruent. That's how you would abbreviate that if you're using that in a proof. And just like there is for supplements, there is for complements too. All I have to do is change one word for the second theorem, and then I'll change the abbreviation here. So this second theorem states that if two angles are complements of congruent angles or of the same angle, then the two angles are congruent. So if you have two congruent angles, and then you have two complements of those congruent angles, the complements are congruent. And you can abbreviate it in a proof writing comp of congruent angles are congruent. So that's really it for the theorems. Now we're going to do some proofs. The first theorem, we're going to prove supplements of congruent angles are congruent. So let's see here. Let me draw a couple angles here. Let's draw some angles. Alright, then in red, this will be angle 1, this will be angle 2, angle 3, and angle 4. Okay, so for the diagram here, we have angles 1, 2, 3, and 4. Now what they're going to give us here, so we are given angle 1 and angle 2 are supplementary. So right away we're given that angle 1 and angle 2 are supplementary. We're also given that angle 3 and angle 4 are supplementary. We were given that also. And on top of that, we're even given that angle 2 is congruent to angle 4. What we're seeking to prove is that angle 1 is congruent to angle 3. So we're given that angle 1 and angle 2 are supplementary, so if you put these together, they'll add up to 180. Angle 3 and angle 4 are supplementary. Put those two together, they'll also add up to 180. And then we're even given that angle 2 is congruent to angle 4. So what we have to prove now is that angle 1 is congruent to angle 3. So we're proving that supplements of congruent angles are congruent. This is how you're going to see it in action. So let's go ahead here. Let's start our columns for our proof. Statements on the left, and then the reasons for those statements on the right. Okay, so I think in this case we'll just start with the given information that angle 1 and angle 2 are supplementary. What else? Angle 3 and angle 4 are supplementary. What else were we given? We were also given that angle 2 is congruent to angle 4. We could put the whole given statement here, and reason 1 obviously is it was given to us. So we have to go from there now. Okay. If angle 1 and angle 2 are supplementary, we know then that the measure of that I better write the measure, or m, angle 1. We know that the measure of angle 1 plus the measure of angle 2 equals 180 degrees, and that the measure of angle 3 plus the measure of angle 4 also equals 180. And that, of course, is by the definition of supplementary angles. So by the definition of supplementary angles, the measure of angle 1 plus the measure of angle 2 equals 180. Same with the measure of angle 3 plus the measure of angle 4. That would equal 180 by the definition of supplementary angles. All right. Statement 3 then, we know 180 equals 180. That's going to be by the reflexive property. So by the reflexive property, we know that 180 equals 180. Next statement then, we can substitute each 180 for the left side of the equation. That means the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4. That would be by the substitution property. Okay, and then now we've got our equation set up. What else do they tell us? Well, they tell us that angle 2 is congruent to angle 4, right? Angle 2 equals angle 4. That's given. So that means in one of these equations, I can substitute one for the other. That's going to mean the measure of angle 1 plus the measure of angle 4 equals the measure of angle 3 plus the measure of angle 4. We can say that also by the substitution property. I'm going to have to continue over here. Normally it would be in one column, but I wanted to draw nice big diagrams and stuff so you could all see this. Step 6 will be over here, okay? Now, what do we see here on each side of the equation? The measure of angle 4, right? If we subtract out the measure of angle 4 from each side, we get that the measure of angle 1 equals the measure of angle 3. Or, by the same thing, we can say angle 1 is congruent to angle 3 simply by the subtraction property. This is all by the subtraction property for step 6. So we have proven that angle 1 is congruent to angle 3. We just proved the theorem that supplements of congruent angles are congruent. So, let's go ahead now and let's sum this up. First statement is that angle 1 and angle 2 are supplementary, as is given to us. Angle 3 and angle 4 are also supplementary. That was given to us. And then angle 2 is congruent to angle 4. All that was given. Now, based on these statements, if angle 1 and 2 are supplementary, that means if you add them together, they'll equal 180 degrees. Same with the measure of angle 3 plus the measure of angle 4, it equals 180 by the definition of supplementary angles. And then we know 180 always equals 180. That's the reflexive property. And then for each 180, you can substitute the left side of the equation in. So we got the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4 by the substitution property. And then in the given information, we're also given that angle 2 is congruent to angle 4. So by the substitution property, we can substitute the measure of angle 4 for the measure of angle 2, and you get the measure of angle 1 plus the measure of angle 4 equals the measure of angle 3 plus the measure of angle 4 by the substitution property. And then last but not least, we can prove that the measure of angle 1 equals the measure of angle 3, or angle 1 is congruent to angle 3 by subtracting the measure of angle 4 from each side by the subtraction property. So we have just proven that supplements of congruent angles are congruent. And we're not going to prove the complementary one because it really works similar. It's pretty dang similar to this. I think you kind of get the idea with the supplementary ones. But I do have 4 other proofs I'd like to touch on. So let me set up the next diagram here and all that. Okay. This one shouldn't be bad at all. Alright, let's see what we got here. We have angle 1, angle 2, angle 3, and angle 4. So we got this nice shape here with these lines with angles 1, 2, 3, and 4. Well, where's this about to go? What we've been given here is that angle 2 is congruent to angle 3. We are being asked to prove that angle 1 is congruent to angle 4. So we were given that angle 2 is congruent to angle 3. We need to prove that angle 1 is congruent to angle 4. This proof isn't going to take very long at all. It's kind of like a review one, really. This one will not take but a minute. Alright, let's see here. You know, once you get familiar with proofs, they can be fun in a way. I know it's different from algebra, but they can be a lot of fun. So let's start with our given information. Okay, angle 1 is congruent. No, that's not right. I don't want to go there just yet. Okay, angle 2 is congruent to angle 3. That's by given information. So the reason for that, it was given to us. Now, based on the diagram here, what else can we deduce from it? Well, angle 1 and 2, those would be vertical angles, right? Angle 3 and 4, those would also be vertical angles, right? Okay, so statement 2 we can make is that angle 1 is congruent to angle 2. And then we can say that angle 3 is congruent to angle 4 by the same reason. And that is going to be by that wonderful theorem that vertical angles are congruent. So by vertical angles are congruent, we can say angle 1 is congruent to angle 2, and then angle 3 is congruent to angle 4. And then really, we can go ahead and prove it in the next step here. We can prove everything in the next step. If angle 1 is congruent to angle 2, angle 2 is congruent to angle 3, right now we can definitely say angle 1 is congruent to angle 3 by the transitive property, right? But if angle 3 is congruent to angle 4, we can also say angle 1 is congruent to angle 4 by the transitive property used twice. So we have angle 1 is congruent to angle 4 by the transitive property And in parentheses, I'll put used 2x, which means used twice. So this was a fairly simple proof. We were given angle 2 is congruent to angle 3. That's given. And then looking at the diagram here, angle 1 is congruent to angle 2, and then angle 3 is congruent to angle 4 by the theorem that vertical angles are congruent. And then by using the transitive property twice, we can prove angle 1 is congruent to angle 4. So that was a fairly simple proof. The other three, they won't be too bad, but probably not quite as simple as this. Let's get into that here, shall we? All right. Let's draw our diagram here. And then we have two intersecting lines next to it. Okay, so here we have a ray with what looks like a rhombus or a parallelogram with angles 3 and 4. Next to it we have two lines that intersect with angles 1 and 2. Okay, let's see where this is going. What we are being given, what we're given is that angle 3 is supplementary to angle 1, and then we're also given angle 4 is supplementary to angle 2. I feel like there was a third thing. Nope, that was it. What we're being asked to prove is that angle 3 is congruent to angle 4. Okay, so we're given that angle 3 is supplementary to angle 1. Angle 4 is supplementary to angle 2. We're simply being asked to prove that angle 3 is congruent to angle 4. So let's go ahead and set the proof up. All right, so let's start with our given information here that angle 3 is supplementary to angle 1, and in the same statement we can also say that angle 4 is supplementary to angle 2. That was our given information, so that would be the reason for statement 1 is the given information, okay? Now, we can do this actually in a few steps here because you're going to see why in a second. Now, we can look at the diagram here. Angle 1 is actually congruent to angle 2 because of vertical angles being congruent. So for statement 2, we can say that angle 1 is congruent to angle 2 by the theorem of vertical angles are congruent. So statement 2 would be vertical angles are congruent. We can prove angle 1 is congruent to angle 2 by that. All right. Now, what we can do is we look at our original statements for this proof. If angle 1 is congruent to angle 2, I just got to pick one of these statements and change out angle 1 for 2 or 2 for 1, vice versa. So let's say here that angle 3 is supplementary to angle 2, and then angle 4 is supplementary to angle 2. We can do that by the substitution property. By the substitution property, we can say that angle 3 is supplementary to angle 2, and then angle 4 is supplementary to angle 2. So all I did was substitute angle 2 for angle 1 in the original statement by the substitution property. And then we are now able to proceed to saying angle 3 is congruent to angle 4. We can go ahead and say that right now. How? Well, angle 2 is obviously congruent to angle 2. They're the same angle. Angle 3 and angle 4 are both supplements of that angle. And it's by that wonderful theorem we just proved that supplements of congruent angles are congruent. So we were able to prove angle 3 is congruent to angle 4 by supplements of congruent angles are congruent. That was nice and easy. So let's break this down here. We were given angle 3 is supplementary to angle 1. Angle 4 is supplementary to angle 2. That was our given information. And then looking at the diagram, we can deduce that angle 1 is congruent to angle 2 by vertical angles are congruent. Okay, so then if those two angles are congruent, by the substitution property, we can substitute angle 2 in for 1 here and say angle 3 is supplementary to angle 2 and angle 4 is supplementary to angle 2. Which means now angle 3 is congruent to angle 4 since supplements of congruent angles are congruent. That's how you do it in 4 steps in the quickest way possible. This theorem has made your life easier. You're going to use the 2 theorems we've learned today all the time. So there is another way we could have done it. I'm not going to show it because it would take a while, but we could have done adding up angles and all that too, and then done some arithmetic with it and subtraction and addition and stuff. But now that we have this theorem, you'll have to do that less and less, which is kind of nice since we've already proven it. And I'm going to go ahead and say we basically proved that complements of congruent angles are congruent. It's kind of the same idea as a supplement one. I'm not going to do the same thing twice, basically. So that's where we stand on that. Okay, draw another diagram here. Let's get rid of that here. Oops, that's B. That's B. Here's C. Here's D. Okay. So here, let's see, we have angle 3, angle 1, and angle 2. All right. So we have a triangle here split into 2 with angles 3, 1, and 2. Well, what have they given us? We are given in this exercise that line segment AC right here is perpendicular to line segment BC right there. So we've been given that line segment AC is perpendicular to line segment BC. We've also been given that angle 3 is complementary to angle 1. So we've been given angle 3 is complementary to angle 1 also. So what do they want us to prove here? That's probably what you're wondering. What are we supposed to prove out of this? Well, we're supposed to prove is that angle 3 is congruent to angle 2. So we're going to go ahead and prove that angle 3 is congruent to angle 2. Okay, so let's go ahead and do our proof. Alright, so let's go ahead and start with our given information. That means, let's see here. Let's start with the first part of the given information. Segment AC is perpendicular to segment BC. That was given to us. Sometimes you'll use the given information in pieces. Well, if segment AC is perpendicular to segment BC, that's going to mean that the measure of angle ACB, excuse me, the whole thing, the measure of angle ACB equals 90 by the definition of perpendicular lines. Alright, so by the definition of perpendicular lines, measure of angle ACB equals 90. So good. Well, what we have now is angle 1 and angle 2. They're subangles, so we can now for there say the measure of angle 1 plus the measure of angle 2 equals the measure of angle ACB. This will be by the angle addition postulate. Which means then the measure of angle 1 plus the measure of angle 2 would equal 90. Since we can do that by substitution, since ACB equals 90, we can say this by the substitution property. Alright. Well, let's see here. This is going to mean that angle 1 is complementary to angle 2 by the definition of complementary angles. Since they add up to 90, that's just simply the definition of complementary angles. Okay, and then here's we're gonna have to continue over here because this is kind of turned into a long proof, but you'll have that. So step 6, we can use another piece of given information, is that angle 3 is complementary to angle 1. So angle 3 is complementary to angle 1. That's by the given information. So this is where sometimes you want to use the given information in pieces. So we have angle 2 is complementary to angle 1, angle 3 is complementary to angle 1. Well, we have that wonderful theorem here now. We can prove that angle 3 is congruent to angle 2 by complements of congruent angles are congruent. Okay, so let's go over the proof here. We were given that, let's start with our given. Segment AC is perpendicular to segment BC. Angle 3 is complementary to angle 1. We start out with here that segment AC is perpendicular to segment BC by the given information. Which this has to mean that the measure of angle ACB equals 90 degrees by the definition of perpendicular lines. Which then means that the measure of angle 1 plus the measure of angle 2 equals the measure of angle ACB by the angle addition postulate. And then by substitution, we can say the measure of angle 1 plus the measure of angle 2 equals 90 by the substitution property. Which then, if these two angles equal 90, that means angle 1 is complementary to angle 2 by the definition of complementary angles. Okay? And then we have angle 3 is complementary to angle 1. That was given to us. So then if angle 1 is complementary to angle 2, angle 1 is complementary to angle 3, or 3 is complementary to 1, however you want to say it. If 2 is complementary to 1, 3 is complementary to 1, we can say angle 3 is congruent to angle 2 by complements of congruent angles are congruent. So there was a proof that used that theorem. I got one more proof and then we are done for the day. Alright, what is the last one here? So, let's draw this line. X and then Z. X and Z there. Y will be in the middle. Well, let's go straight up here first. This will be line, that'll be S. Here's going to be R. Here's going to be T. Okay. So we have here this diagram. We have line XZ with Y in the middle, and from point Y we have rays YR, YS, and YT. And then we're given some angles with those. Let's see, we got 3, 1, 2, and 4. So we have angles 3, 1, 2, and 4. So what are we given? What do we have to prove? We are given that the measure of angle 1 equals the measure of angle 2. We're also given that the measure of angle 3 is equal to the measure of angle 4. Alright, so what are we being asked to prove here? We are being asked to prove that ray YS is perpendicular to line XZ. So we've been given that the measure of angle 1 equals the measure of angle 2, the measure of angle 3 equals the measure of angle 4. We got to prove that ray YS is perpendicular to line XZ. So let's get started here. Alright, so this one might be a bit of a doozy. I'm not going to lie to you about that. I'm going to make this one kind of big because I don't want to run out of room on the board. We'll have statements here. We'll have reasons here. Okay. So to begin our proof, let's start with the given information. The measure of angle 1 equals the measure of angle 2. And then the measure of angle 3 equals the measure of angle 4. That's going to be by your given information. Okay, so now we've used our given information. Well, we can't yet prove that any lines are perpendicular whatsoever. All we have to go on here, unfortunately, is that you add up these four angles, you'll get 180. So let's go ahead and do that here. We'll say the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 is equal to 180. And that's going to be by the definition of supplementary angles. That's all we can say there. All right. And then here's where we get a little bit clever. So we have all four angles added together to equal 180. But we know measure of angle 1 equals angle 2, right? Angle 3 equals angle 4, so we can do some substitutions here. We can say the measure of angle 1 plus the measure of angle 1 plus the measure of angle 3 plus the measure of angle 3 equals 180. See how I did that here? In this equation, I put angle 1 in for angle 2. I can do that. And then I put angle 3 in for angle 4. I can also do that. And this is actually going to be by the substitution property used twice. Substitution property used twice. Okay. Now let's do some addition. Measure of angle 1 plus the measure of angle 1, so that's twice the measure of angle 1, plus twice the measure of angle 3 equals 180. That's simply by the addition property for reason 4. Now if we look at this equation, can't we factor out a common 2? Yes, we can. We can factor out a common 2 and divide both sides by 2. If we do that, you'll get the measure of angle 1 plus the measure of angle 3 is equal to 90. That would be by the division property. All right. So the measure of angle 1 plus the measure of angle 3 equals 90. Well, we know that the measure of angle 1 plus the measure of angle 3 equals angle XYS. So the measure of angle 1 plus the measure of angle 3 equals angle XYS. That's by the angle addition postulate. So measure of angle 1 plus the measure of angle 3 equals angle XYS by the angle addition postulate. And now by substitution, I can say that the measure of angle XYS equals 90. Because if the measure of angle 1 plus the measure of angle 3 equals XYS, then that means it equals 90 by a matter of substitution. And then I have reason 8. I have statement 8, which now is, we can now say that ray YS is perpendicular to line XZ. We can finally say that on the 8th step. Well, how can we say that? I'm going to put the reason right next to it here because we're out of room. Simply by the definition of perpendicular lines. Okay, so let's break down this proof here. So we were given that the measure of angle 1 equals the measure of angle 2. The measure of angle 3 equals the measure of angle 4. That's our first statement with the given information. All we can deduce at first is that the sum of these four angles equal 180. That's all we know for certain. Well, that's by the definition of supplementary angles. Now, we have here, since the measure of angle 1 equals the measure of angle 2, in the equation I was able to substitute that in for angle 2, and then the measure of angle 3 equals the measure of angle 4, so I was also able to substitute that in for angle 4. So then by the substitution property used twice, I could say the measure of angle 1 plus the measure of angle 1 plus the measure of angle 3 plus the measure of angle 3 equals 180. And then by collecting like terms and adding them up, I could say twice the measure of angle 1 plus twice the measure of angle 3 equals 180. That's simply by the addition property. Which then we determine both sides of the equation have a common factor of 2, so the measure of angle 1 plus the measure of angle 3 is equal to 90. That's by the division property. And then we also could see from the diagram the measure of angle 1 plus the measure of angle 3 is equal to the measure of angle XYS. So that's by the angle addition postulate. And then we can do substitution property to say that the measure of angle XYS equals 90. And then with ray YS and line XYZ intersecting, and you have one right angle, by the definition of perpendicular lines, you can declare that ray YS is perpendicular to line XZ. So that's all there was to it. So that's it for this lesson. The next lesson we're going to talk more about, we'll talk about parallel lines, we'll talk about transversals, we'll talk about parallel planes, we'll talk about skew lines, and some other things. So I hope everyone has a good day. Take care.